In engineering mathematics, Laplace transform is one of the most important topics. Today's lecture will be entirely dedicated to understand what is the basic concepts of Laplace transform and then what are the different rules in Laplace transform. So basically, Laplace transform is nothing but an integral. We all know if I write d by dx, now d by dx is nothing but an operator of derivative. So d by dx of some function if I write, it gives me some answer, let us say g of x. So d by dx is called as an operator of derivative. Likewise, if I write integral and some function and dx, so integration of some function, again I get some kind of an answer. Let us say g of x is the answer of integration of f of x. So here also this integral dx is called as an operator. This d by dx is called as an operator. So this derivative and integration we have already learned in our lower standards. So what is a Laplace transform? What is the need of understanding Laplace transform? Observe carefully. So Laplace transform is basically an integral. A Laplace transform is an integral. It is varying from 0 to infinity. So Laplace transform is an integral having limits from 0 to infinity, and it is an integral of what? What is the function that is present inside the integral? The function that is present inside the integral is e raised to minus of st into f of t dt. So that's a Laplace transform. Now this is a Laplace transform of what? This is a Laplace transform which is denoted by L. The way we represent derivative by d by dx, the way we represent integration by integral and dx, exactly same way we will represent a Laplace transform by L. Laplace of function is f of t. So basically Laplace of a function f of t is an integral whose limits are from 0 to infinity, e raised to minus st f of t dt. Now try and understand the terminology in this particular formula. When I write f of t, I am telling you that f of t is a function of t. That means t is your variable. T is the variable. So these limits that I have written over here for the integral 0 to infinity, these are the values of t. So t equal to 0 to t equal to infinity. We are finding the Laplace transform of what? We are finding the Laplace transform of the function f of t. So this is the function whose Laplace transform is to be obtained. So if I want to find Laplace of a function, it is basically an integral which whose limits are from 0 to infinity, which is given as e raised to minus st f of t dt. So t becomes my variable, so integration is carried out with respect to t. Further, e raised to minus st, this s that I have written over here, this s that is written over here, this is basically some constant. It can be anything. Any constant number you can take. So understand the terminology. We are finding the Laplace transform of what? Of function f of t. What is a Laplace transform? A Laplace transform is basically an integral whose limits are from 0 to infinity, t equal to 0 to t equal to infinity. T is my variable. It's an integral of what function? It is an integral of e raised to minus st f of t dt. Now, I'll tell an example to understand how this integral is evaluated and what is the answer it is going to give us. Let's take an example. Now this is a very important example. If I give you Laplace of 1, I am going to ask you how to find Laplace of 1. So what is the answer for Laplace of 1? So if I want to get Laplace of 1, I should go back to my basic formula. This is a basic definition of Laplace transform. Laplace of a function, it is given by an integral. So Laplace of my function is 1. That means in place of f of t, I have 1. Now remember, this 1 is actually t raised to 0. There might be a confusion how 1 becomes a function of t. So f of t, so this is 1 can be written as t raised to 0. It ultimately becomes a function of t. T is actually time here. So Laplace of 1 if I need to find, I will go back to my formula. It says integration 0 to infinity. So let's write integration 0 to infinity. Integration 0 to infinity. Remember, this 0 and infinity, these values belong to your variable t. All our derivatives, all our integration was discussed with the variable x. So So we have to train our mind to understand that the new variable that we are using in Laplace transform is not x, it is t. So whatever things we will be learning in Laplace transform everywhere, the variable is going to be t. So t equal to 0 to t equal to infinity. Then the formula says you that e raised to minus of st. So let's write e raised to minus st. E raised to minus of st into f of t, your function. You are finding the Laplace of 1. That means your function is 1 here. So I write 1 and dt. So that's integration of e raised to minus st. Now, I have told number of times, if you want to really learn engineering mathematics, the most important thing that you should be doing is your integration and derivatives very thoroughly that you have learned in your lower standards. So make sure that if you are not aware of any of the formulas of integration or derivatives, go back to your lower standards, find out those books and start revising all the formulas. Start revising all the basic concepts of integration. Otherwise, Laplace transform and the coming topics will be very difficult for you to understand. So make sure that you are learning your basic concepts very well. So here I am going to integrate e raised to minus st. Multiplication by 1 has no meaning over here. I get the same function e raised to minus st back. If you recall the integration of e raised to ax dx, the integration of e raised to ax dx is actually e raised to ax upon a. You should never ever forget to divide the answer by the coefficient of x. We remember that integration of e raised to x, integration of e raised to x is e raised to x again. Integration of e raised to ax. So a is a coefficient of x. So the answer comes e raised to ax upon a. You should always remember to divide the entire answer by the coefficient of x. So it is a over here. So in my case here, if you observe this and compare it to the formula e raised to ax. See, we have learned entire integration in terms of x. So we have to switch our mind from the variable x to variable t. In your formula, in your problem, variable is t. So it is like x for me. T is like x for me. Then it is told a is the coefficient of x. In my case, the coefficient is minus s. So e raised to ax has integration e raised to ax upon a. E raised to minus st will have integration e raised to minus st. E raised to ax integration is e raised to ax. Then e raised to minus st integration is e raised to minus st. T is my variable. So I will never ever forget to divide the entire answer by the coefficient of my variable. The variable was t and its coefficient is minus s. I will divide by minus s. Since the integration is carried under limits 0 to infinity, I should put the limits also. So the limits are put up as t equal to 0 to t equal to infinity. Remember, these values belong to t and not s. S is some random constant. S is a constant. T is your variable. So these values belong to t equal to 0 to t equal to infinity. So that was my formula for integration of e raised to x. I have used it in my question over here. E raised to ax, e raised to minus st. Answer came e raised to minus st upon minus s. Now I'm going to put the upper limit and the lower limit. Now, as I said, s is a constant. So I can take minus s outside. So I have taken minus 1 upon s outside the integral. So I'm going to put upper limit and the lower limit. So minus s was a constant taken outside the limits, outside the integral. So e raised to minus s into upper limit is infinity. So place infinity in place of t. So e raised to minus of s into infinity. Minus of e raised to minus of s into 0. So that would give me minus 1 upon s e raised to. Now s is a constant number. Multiplies with infinity. You get e raised to minus infinity. Minus s is a constant number, multiplies with 0 and the minus, everything will become e raised to 0. Now, this is a very important concept. Try and recall every single time. E raised to minus infinity. If you remember, a raised to minus m can be written as 1 upon a raised to m. So, e raised to minus infinity can be written as 1 upon e raised to infinity. See, I have used the law of indices. A raised to minus m, it is 1 upon e raised to m. So e raised to minus infinity is 1 upon e raised to infinity. Now, t is some number 2.71328 raised to some infinity will give us infinity, a very large number. And 1 upon infinity, we know it is 0. So this is a very important result that we will be using in Laplace transform. So e raised to minus infinity, remember it, the answer is 0. So I will write it now. minus 1 upon s, then a bracket, e raised to minus infinity, it is 0. Minus, we all know e raised to 0 is going to be 1. A raised to 0, the answer comes 1. So e raised to 0 also 1. So minus 1 by s, 0 minus 1, finally the answer is 1 by s. See, I started my problem with 1. I need to find the Laplace of 1. 1 is a function of t. 1 is a function of t. It is equal to t raised to 0. 1 is a function of t. I have evaluated an integral because I now know that Laplace is an integral. So I have evaluated the integral and my answer came 1 upon s. That means a function of time t is getting converted into some constant s. That is what a Laplace transform is. A Laplace transform will convert a function of time into a constant, 1 upon s. So from here, I can understand that Laplace of 1 is 1 upon s. That becomes your first formula. There is a big list of formulas that you want to remember. We will be definitely discussing most of the formulas in our coming lectures. So, Laplace of 1 equal to 1 upon s, that's the first formula. I'll give you one more. Let's take one more. So this is 1 upon s. If I give you a function, let us say sine 80. Observe carefully. I want to find Laplace of sine 80. So sine 80 becomes my function. See, f of t sine 80. I know my formula for Laplace transform. It says integration 0 to infinity. I am very thorough that 0 to infinity, these are values of what? These are values of a variable t. T is my variable. T equal to 0 to t equal to infinity. Then the formula says write e raised to minus st. Let's write e raised to minus st. Then the formula says you write your function. You are finding the Laplace for sine 80. So I'm going to write here sine 80 and dt. Isn't it? Now people, e raised to minus st into sine 80 is a very big integral. This integral has been taught in your lower standards when you learned your 12th standard integration. For there, this integral was taught to us. Now, as it is going to take too much time to evaluate this integral, what you should be doing is, you should be remembering two most important formulas in integration. Now, these formulas I am going to use number of times in solving questions. E raised to minus st into sine 80. This actually looks like integration of e raised to ax into sine bx dx. I hope you should be recalling this particular integral from your lower standards. So integration of e raised to ax into sine bx dx. That's your question. I want to write the answer for this one. You have to memorize this particular formula. I will write the formula. Make sure that you note it down somewhere and keep on revising this formula number of times. Whenever such kind of question comes, you should be immediately able to identify the type and write the formula accordingly. So e raised to ax and sine bx dx. It gives e raised to ax upon a square plus b square, then a bracket, then the first constant is a, so I'm going to write a here. The formula is written for e raised to ax into sine bx. So I'm going to write sine bx here. Observe carefully. A was the first constant. The formula is obtained for e raised to ax into sine bx. So sine is given the preference. Then a minus sign will come, and then the next constant is b, and the other trigonometric ratio is cos bx. That's your formula for e raised to ax into sine bx dx. Now, I'm going to give you one more formula, and it is very much correlating with this formula, e raised to ax and sine bx. The other formula is e raised to ax into cos bx dx. Now, as I'm telling you again and again, you have to remember these two integrals very thoroughly. So make sure that you make note of these two formulas somewhere in your book. So e raised to ax upon a square plus b square. Isn't it? It's not very difficult to remember now. So it is almost same. E raised to ax upon a square plus b square. Then a bracket, then the first constant a. We are finding the integral of e raised to ax cos bx. So I'm going to write cos here, cos bx, and then I will write a plus sign. So that's one change that you should be always noting. For sine, the sign is negative sign, and for cos, the sign is positive sign. So cos comes plus, sign comes minus. So make sure that you remember these differences. And obviously, next is b and sine bx. That is your formula for e raised to ax sine bx and e raised to ax cos bx. In my question, I have to use the formula for e raised to ax sine bx. Now correlate this to the question and the formula. The question and the formula. Try to correlate the two of them. E raised to ax. Remember, we have learned all our integration derivatives in the variable x. We are now shifting our variable from x to t. So keep on telling your mind again and again that t is my variable. So t is like x for me. So t is like x for me. So e raised to a is minus s, x sine a t, t is like x for me. So this is correlating with this particular formula, e raised to minus e raised to ax sine bx, e raised to ax sine bx, e raised to ax sine bx, and then dx. So I'm going to use formula for that. So my answer comes, therefore, Laplace of sine at now becomes equal to. So I'm going to straight away use the formula. No need to do any kind of integration. I know the formula, and do not worry, make use of the formula. If the question comes, you can directly use the formula. You will definitely get full marks for this particular question, the solution. So make sure you use the formula directly. So I'm going to use it directly over here. So it says use e raised to ax, that means e raised to minus st will come as it is. I write e raised to minus st upon a square. In our question, a is taken the place by minus s. Minus s is taking the place of a. So I'm going to write minus s square, a square. Minus s, and I'm doing square of it, I will get s square. Then plus b square. In our question, b is occupied by a. So I'm going to write s square plus a square. Then a bracket. Then I write a. I can see a in my formula. In our case, a is minus s. I write minus s. Then it is telling me to write sine bx, which is sine at for us. So into sine at. Then there is a minus sign. The formula tells you write minus sign. Then you write b. In our case, b is a. So I'm going to write a here. And then cos bx. So I write cos a t and close the bracket. Now remember, this is just the formula for the integration of e raised to minus st sin at, but the integration is under limits. 0 to infinity are the limits, so I should not forget to put the limits as well. So let's put the limits. So t is 0 to infinity. T is 0 to infinity. Now, as I've already told you, e raised to minus infinity was 0. Upper limit is infinity. So I'm going to place infinity in place of every t. Wherever you find a t, start substituting the value infinity. So t sine infinity, t cos infinity. You should be recalling from your trigonometries that sine infinity and cos infinity, these are finite numbers lying between minus 1 and plus 1. I'm going to write over here sine infinity and cos infinity. So very important concept. Sine infinity and cos infinity, they are both finite numbers lying between minus 1 and plus 1. So minus s sine infinity minus a cos infinity will be some kind of a finite number which might lie between minus 1 and 1, because sine infinity and cos infinity, both of them are some numbers, finite numbers lying between minus 1 and 1. So for infinity, this particular term is a finite number, and I am going to replace t as infinity in e raised to minus st also. So it becomes e raised to minus infinity. E raised to minus infinity, I know it is 0. So e raised to minus infinity is 0. 0 upon anything is 0. And just now I have discussed that this bracket is going to give me some kind of a finite number. I am not interested what that finite number is. So this is a finite number. This is e raised to minus infinity, which is 0 upon s square plus a square. The ultimate answer, 0 into finite number upon s square plus a square, is going to be 0. So the upper limit gave us the answer 0. Let's talk about the lower limit, minus. Now the lower limit is t equal to 0. So over here, if I put t equal to 0, it becomes e raised to 0. we all know that e raised to 0 would become 1. So I'm going to write 1 here. Upon I have s square plus a square, as you can see here, s square plus a square is already there. Then lower limit t is 0, we all know. So I'm going to replace every single t that is present in my solution with 0. So t, I'm going to put 0 over here. That becomes sine 0. I hope everyone knows that sine 0 is 0. So this term also becomes 0. Sine 0 is 0. And cos 0 is 1. So 0 minus a into 1. So I get minus a. So my answer becomes a upon s square plus a square. So that's your next formula. So sine 80 is one of the standard functions. As I've got the Laplace of 1, it came 1 upon s. Likewise, I'm going to write Laplace of sine 80 as, see the integral, see the entire solution, Laplace of sine 80. I began, I solved the entire integral, and then the answer came a upon s square plus a square. A upon s square plus a square. Obviously, s is a constant, a is also constant. So that's your formula for Laplace of sine 80. Now, I'm going to give you this as a homework. Laplace of cos 80. You make sure that you do that Laplace of cos 80 on your own. Cos 80, I've given the formula e raised to ax and cos bx dx. You got to use this formula to get Laplace of cos 80. So, I'm going to write the answer for that. Laplace of cos 80, it is going to be simply, there's a very small change in the two formulas. It is going to be s upon s square plus a square. These are the first three standard formulas of Laplace transform. So Laplace of 1 by s. Laplace of sine 80, a upon s square plus a square. Laplace of cos 80, even though I have not derived it, but I have already given you the formula. Make sure that you solve using this particular formula and get your answer. The answer is going to come s upon s square plus a square. And you should be knowing that Laplace transform is nothing but what? Laplace transform of any function is an integral from e raised to minus st f of t. T is your variable, x the constant, and the integral varies from t equal to 0 to t equal to infinity. Very important. T is your variable, s is a constant. And have you observed whatever functions I took 1, I took sine 80, I took cos 80, whatever functions I have taken, every function is giving me the answer in terms of s. That is why Laplace of f of t is also written as phi of s. So whenever you get Laplace of a function, the answer usually comes in terms of s. S is a constant, t is time dependent function. So that is what your Laplace transform is. Make sure that you understand and revise Laplace transform very properly. Thank you so much for watching the video. Have a great day.